Okay, we're going to continue on with Chapter 6 in Project Management. In the last video, we talked about project control and what a project manager does and how they control a project and making sure everything gets done on time. There are specific tools that a project manager can do in creating a schedule, and one of them is a Gantt chart. Some of you may have seen a chart like this before. It's a very typical chart that's used, and it's used quite often in industry. It's frequently used in industry. Probably the most used type of tool for project management. Again, it was developed by Henry Gantt in 1861. He was a mechanical engineer. I would always like to have something named after me. And this would be kind of cool to have this, right? So here's an example of a project. This project has a list of project tasks. So we have some research that's being done. This is the development that's being done. Here's prototype and production that's done. And this is the schedule overall for XYZ. And if we look at the top, we see we have dates going across on the top, right? Time frame. And this could be, again, in months, right, like it's showing. Could be weeks. It could be days. I typically wouldn't go less than days, right? We don't go to hours usually. And what we then do is we put in our tasks. So the first one on here is research. So they're going to research some project. They're starting out in January, and they're giving it a time frame, right? They're going from, looks like mid-January, and it ends right around the beginning of March, right? They're saying development then starts somewhere in that's end of March. May. Sorry, that ends in May, end of April. So this starts in the middle of March, right? And then supposed to finish at the end of June, July, right, is when it's ending. And then you have prototype production is the next one. You'll see these bars have some red filled in on them, right? This whole red area in here is filled in. That's showing, like for research, how much is actually completed. So all of the research has been completed. We see on development that we are up to this dash line. The dash line is today's date. Okay, so that's where we are right now. And then, so development is right on schedule, and we see prototype production is ahead of schedule. That's why our overall project is a little bit ahead of schedule. Okay, so that's how this Gantt chart works. There are relationships, though, that we set up in a Gantt chart. There are three fundamental types of relationships. The first one is sequential, and we're going to use this example of designing some cartridges, some like print cartridges and things. And what we do is we need our specifications. So this is, of course, from our define phase, right? We need to be able to complete this task first, and then we can start our concept generation and selection. We can't design any beta cartridges until this step is done, and once that is done, then we can test our design of cartridges. So you see it follows along sequentially, right? It's one right after the other. Another type of relationship that we see sometimes is parallel. Things can be done at the same time. So here we've completed our design of our beta cartridges. We've created those and decided what we want. And now we're going to go into the next phase of our schedule. And part of that is to produce beta cartridges, and the other part is to test the program itself. We don't have to do those sequentially in the same order, right? We can do those at the same time. So as soon as this one is done, we can work on both of these at the exact same time. And when they are both done, then we can test the cartridges. But we can't test them until both those activities are done. I could have, if I wanted, done them sequentially like above, but the problem with that, it would take a lot longer, right? So sometimes we do parallel activities to shorten the time frame of our Gantt chart or overall schedule. The last one is coupled activities. And these activities are ones that are kind of dependent on each other. And they're done at the same time. So here I've tested my beta cartridges, and now I'm going to design my production one. I'm going to design the mold and design the assembly tooling all at the same time. But as you see, there's arrows showing between them, and that means that they're dependent on each other being accomplished. So there's a lot of communication between these different groups of people, right? Because I may be designing my production cartridge, and if I designed it sequentially like the first one and said, okay, I'm done with my design, and I gave it to the mold builders, the plastic injection mold builders, if I gave it to them, they'd say, no, I can't produce this through injection molding. You have to change these items on here, or I could make it cheaper if you would have done that. So if you talk about it in a coupled time frame, it'd be a lot shorter. Same with assembly tooling, right? If they're talking also with the design people, they may say, if you put in these features, I can assemble it a lot faster and a lot quicker. So once these three tasks all start and stop at the same time, then this one can be completed. The difference with a parallel is there's no communication that's necessary between the two, and they don't have to start and stop at the same time. My test program could be much shorter in duration than my design cartridge one. But this one, the coupled one, they all essentially end at the same time, start and stop at the end at the same time. I could start my test program in parallel later if I wanted, right? Sometime a little bit later or whatever. So what does this look like in a Gantt chart? Okay, let's look at this in a Gantt chart. So here I've got my dates on the bottom. Typically, though, I would put them at the top. It's a much better place to put them. Here I have my tasks again. You should have names of people under here also. Who's responsible for what the tasks are. So here are my tasks. Again, my first one is to receive and accept my specifications. Right after I do that, you can see that it starts immediately after that my concept generation. Right, one starts, the next one starts. Then it says design beta cartridges is next, and you'll see I can't do that until my concept generation and selection have been completed. So that is the next one on the chart. Then after that, I said I could do these things in parallel, right? I could produce my beta cartridges, and I could develop a test plan for it. So here's my test plan. You see my test plan is shorter than what my beta cartridges are to produce them. I'm a little behind in my schedule on that, you'll see. I could have shifted this out a little more, right? I could have put it out here more, whatever. But I don't want to get it past that time frame. But it gives me some wiggle room or float time to move it back and forth there. Once this one is done, right, as soon as one of these two, the last one is done, then I can start the testing of my beta cartridges. But both of those tasks have to be done before I can start it. This is again, my parallel one. Okay, I'm going to test my beta cartridges. Now I've come out successfully. I'm going to produce the production cartridges, design the mold, and design the assembly tooling. And you'll see that all of these start and stop at the same time. These are my coupled activities. And then you'll see as soon as those are done, we can go on to the next step of deciding the tool assembly, purchase assembly equipment. All right, those can also then start and go on. Okay. So this is the rest of the schedule, and we'll look at more of that in the next type that we'll be doing. So the next one that we'll be doing will be PERT charts. We'll start the next lecture with PERT charts.